So now we're inside our building and we're looking at the service entrance, the panel box. This could be in the basement or on the first floor. But we've had the power that came into the large pipe up here from the pole or from the underground feeder through the meter and into this panel box. And the reason I put this graphic up first is that our architectural requirements are to provide clearance around this. So you can see the 36 inches in front, 30 inches of minimum on either side or of the center line of it or width-wise. And the idea is to give this a space is to protect anyone who's working on this panel box um, from falling into the panel if they should have a short circuit or while they're working on it or they're grounded and they've caused some kind of they've accidentally touched a live wire. They're rendered unconscious. You don't want them falling into the panel. You want them to have clear room to fall away or get away from the electrical hazard. Another requirement when we put panel boxes in spaces is they can't be disguised. They need to be apparent in the room, which means you can't hang photographs or hide them in any way, which is something to consider when you're placing them in the inside of interiors of residence and commercial buildings. This is a look of a panel box. The blacks are all the circuit breakers, the branch circuits that come off of the main supply. This is a modern looking panel box, and we are able to detect a short circuit by these being out of position, but we're also able to turn the power off here and then work on that branch circuit that's coming off of it. I put this graphic in just for you to think about when you're making site visits, especially if you're planning renovations. On the left, we have a modern installation. It looks like could be a multifamily building. We have two service panels. That very clean, modern. You'll notice all the electrical wires coming out are clearly labeled. A lot of indications to make it clear for somebody who's working on it and doing maintenance. Over here would be a typical older residence that you might be called in to do a kitchen renovation. If you look at this panel box, you'll notice that it no longer has circuit breakers. It has an old traditional type of glass fuse, which is similar to a light bulb. And in this case, overcurrent, a short circuit will require the filament fuse part to be blown out or melted away and turning off power to the circuit. These are typically no longer used, and in most renovations, they are discarded, and panel boxes are replaced with modern circuit breaker panels. So here we have a modern panel box. Just showing you this idea of there's a neat workman-like composition to it. Sometimes you'll open up these panel boxes and they'll be just strewn with wires, very difficult to decipher. This is a nice example. This is a detail of a circuit breaker. I think it's important that this is a 220 volt circuit breaker supplying 40 amps to a branch circuit, which might be a range or an air conditioner. And the way we achieve that is that it picks up both of the wires that come in. Across these two is 240 volts. Across any single to the ground, which is what this aluminum wire is here, we have 110 or 120 volts. So this is a 220 volt panel breaker or your circuit breaker. And this is just this is an installation that I did on my own residence, and this is just the process of it. The idea of trying to be neat and orderly with the placement of the wires, taking pride in that, it can help you to understand if you have a good electrician working for you or not. So we've already discussed this idea of fusing systems, the standard glass, and the only ones you'll probably see in modern times now is the circuit breaker. And at the end, we're going to go into codes and we're going to look at the other kind of way of interrupting a circuit, and that's called a ground fault circuit interrupter. And that's there for protecting from electrical shocks. And we are required to use those in specific locations. So this idea of branch circuits, I was talking about the idea of looking at an older renovation and maybe needing to add some a new kitchen remodeling. And this is kind of an illustration of the idea of branch circuits. So we have the service panel here. A kitchen might be supplied with power all of its own, and I'll discuss that a little more over here. But a branch circuit might also supply many rooms with what are outlets. So here we have a dining room and a living room, and the branch circuit is supplying the floor outlets for multiple rooms, all on the same circuit. But when we get to kitchens, kitchens have a really high requirement for electrical power. So we have a lighting circuit controlling lighting. We have countertop lighting circuits, or excuse me, countertop outlets that may be required. And when we have specific appliances that get sometimes their own individual service, like in this case, the refrigerator may have its own branch circuit, and a range would obviously have its own branch circuit. So a single kitchen may have 5 or 10 breakers supplying it, depending on how elaborate it is. We should be able to recognize electrical wiring systems for what they are. So here we have the idea of conduit systems. They're rigid conduit systems that protect the wiring. They allow for flexibility in wiring. They're protective, so they can be exposed in places where they might be subject to damage. So they can be very useful to us. We can run multiple conductors through it, and up to a limit as the code allows. So you can only pass so many wires through before the code says that's the maximum. Rigid conduit also has another form called flexible conduit. So we now can snake this through other more convoluted forms, or have it flexible as it branches off to supply something like an air conditioner. So we have flexible conduit. We have what's called liquid type conduit that's covered with a coating that protects water intrusion for applications where it may be exposed to water. And then the final cladding or conduit system we have is called BX cable. And this sometimes is required in commercial installations where the, just a code requirement for a more durable cladding around the electrical conductors. In typical residential construction, though, we use a non-metallic sheath cable. So there's a plastic coating over it. More slightly, well, I don't know if the term more durable, but not unlike an appliance cord where you have a conductor covered with a wrap around it. In this case, it's to control cost and make it flexible to route through the system. So we have an indication by color how much current they're able to carry. Typically, you'll see the yellow and the white, and the idea between a 15 and a 20 amp service. So 14 gauge wire, a higher number, smaller gauge, less current, smaller, or excuse me, smaller number, more current. This is 20 amp. So the numbers are moving in an opposite direction. A much larger conductor would be a 6 gauge or a 0 gauge, and that's illustrated here. So we have this idea of wire gauge and the idea that the numbers are really running in the opposite direction. Something I think is really important is this understanding of grounding. Grounding is important for the functioning of the electrical system and for life safety. So all of our power is tied back to grounding, which means if we have a fault in the electrical supply, we can remove that fault from creating shock injury by driving that voltage back to the ground source. And we're required when we do service installations or electrical installations to ground the panel box and all of the outlets. All of the outlets have a third pin which goes back to earth ground. And this concept is to effectively create a safe situation for all of the electrical appliances within the building because of this reference to an earth ground. And you see that in a panel box with these green wires here, which are ground wires. They are connected across to one of the legs of the more complicated than you really need to know. But all of these are typically grounded to a neutral ground bus. And really haven't explained that effectively enough in this section, but we're going to come back to this idea of grounding when we talk about codes and ground fault circuit interrupters for life safety.